get-go here, I jumped right into subtracting polynomials. So one thing I see a lot if someone is asked to simplify this is people just start distributing. 13 times negative 7, 13 times the 2, and that's absolutely not what you're supposed to be doing, right? Because there's a minus sign in there. The only time you're distributing is when those parentheses are touching each other and are back to back. That's the indicator for multiplication. So here, the big key is the fact that you're subtracting not just the first term of the second polynomial, but the entire polynomial. So every single term, and that, of course, kind of switches the signs for all of those. So you can write that step out. As you get more upper level, I think you should start to be able to just think through. 13 minus negative 7 is 13 plus 7, so it's a 20. Negative 9 minus a 2 will be a negative 11. Negative 7 minus a negative 5 will be negative 7 plus 5, so that's a negative 2x. And 1 minus 9 is negative 8. And we're done. Okay, so simplifying just means distribute, combine like terms, which is essentially what we did. When you square a binomial or a trinomial, you have to think about the foiling that happens, right? How many of you rewrite it like this? Raise your hand if you do that, and then start foiling. Okay, good. So that just really puts it in front of you. You see the whole thing. 5x times 5x is 25x squared. Your outer gives you 15xy. Your inner, 3y times 5x, gives you another 15xy. And then your last gives you 9y squared. And then, of course, you combine like term. What not so careful students will do is just square this to get 25x squared, square this to get 9y squared, and so they always miss the middle term by doing that. Okay? Does anybody know the shortcut? Like, if you wanted to avoid, and again, because we're going to do this fairly often, obviously we can get your first term just by squaring the 5x and your last term just by squaring the 3y. How can we get that without going through all that writing? I have a pretty big callus on my fingers, so I like to not write as much as possible. What's the shortcut? Go ahead. So if I multiply 5x and 3y, it's going to give me 15xy. Right, and then just double it. So you're kind of thinking about what you would have done. Your outer and your inner is always just going to be this times this, outer times inner. And you're always going to have two of those, so that's exactly right. You just multiply those, 15xy, and double it, and you can jump right to that so as to not necessarily need. Now, if you feel like that shortcut is not going to sit with you and you keep making careless mistakes, by all means, write it out, visualize it, because I'd rather the accuracy than the speed, but just as you get more comfortable, if you ever had to do like 100 of those in a row, you might think about using that shortcut. And then in number 3, you saw some of these in Algebra 2. The initial instinct, I would guess, and I'm pretty sure just from the experience over the years, is to distribute the 3x, distribute the 2, and distribute the 5y. I don't know, triple distribute, if you will. Is there anybody else that, after being well trained last year, sees that differently? No? Yeah. Yes. So if you kind of notice that this is 3x plus 2 plus 5y, and this is 3x plus 2 minus 5y, you can then treat these as the conjugates that they are. The binomial plus 5y and the same binomial minus 5y. Those are conjugates. The beauty of conjugates is that when you kind of now go back to that FOIL or the double distribute concept, 3x plus 2 times 3x plus 2, we now have a nice shortcut for 9x squared. 2 times 3x is 6x, and I'm going to double that to 12x. And then 2 squared is 4. So there's the 3x plus 2 times 3x plus 2. Then when you go to your outer 3x plus 2 times negative 5y, you don't even have to do it. Because then right after 3x plus 2 times positive 5y, that's the beauty of conjugates. One will be positive on your outer, one will be negative on your inner, or vice versa. Regardless, with one being positive and negative, they're always going to cancel when you're dealing with conjugates. Okay? That's why we use conjugates, to rationalize those denominators that we saw yesterday. So you don't have to worry about that, and then your last term is just 5y times negative 5y, which is negative 25y squared. So if you can see it for that structure, it's just going to save you, again, time. Okay? Otherwise, if you're triple distributing, you're going to have 9 terms by the end of all that, and then you're going to have to combine all those. You'll get the same thing, but it's just a different way of seeing it. So that also when you're done, you can also see this for the difference of perfect squares that it is. Because this is a perfect square trinomial. That was 3x plus 2 squared minus 25y squared. That's a perfect square, that's a perfect square, that's a difference of perfect squares. Now, I wouldn't write that because that's not in simplest form. But just so you see, that's what happens also. When you multiply conjugates, you get the difference of perfect squares. Which you guys know, because I'm almost positive you all could factor that and go backwards using that idea, right? Difference of perfect squares turns into conjugates. So this is sort of just using that idea forward. When you multiply conjugates, you get the difference of perfect squares. Okay? So just some connections to be made. Speaking of conjugates here, just some shortcuts. So a times a is obviously a squared. Your outer is going to be minus ab, your inner is going to be plus ab, so those will cancel, and then positive b times negative b will be minus b squared, and there's your difference of perfect squares. So just showing you via simplified examples the properties I've been talking about. When you square this binomial, the shortcut's going to be a squared. What do you think that middle term is going to be, John? Very good. A times b gives you ab, and then double that, 2ab plus b squared. The subtraction version is going to look just the same, except for it's a times negative b, so that's minus ab, and then you'll double that, so it'll be minus 2ab plus b squared. I don't want you to memorize the rule for cubing a binomial for cubing a binomial. So we're not going to just have you memorize the shortcut. This is a little bit easier to wrap your head around, and it just makes more logical sense. This will have a decent pattern, but I think it's a higher risk than it is a reward if you mismemorize something even slightly. And it comes up so infrequently so that I don't think memorizing the rule is going to be helpful to you. But just to I'll just do one of these. If you ever were asked to cube something, obviously, and I'm going to write it this way, you multiply the first two first. Now you can take the shortcut there on the a plus b squared part. So that's going to be a squared plus 2ab plus b squared. And then, I don't know what you want to call this, triple distribute. Then just go through one more time. So you'll see what it is going to be. A cubed plus a squared b. Move on to your 2ab. So that'll be plus 2a squared b plus 2ab squared. And then on your last one, I'm just going to keep putting the a first just to be consistent. Plus ab squared plus b cubed. So when you go to combine like terms, I've got a squared b plus 2 of them. That's 3a squared b's. I've got 2ab squared plus 1ab squared, so that's 3ab squared plus b cubed. I have no doubt that some of you could memorize that. It's going to come up so infrequently, I wouldn't boggle your mind down with that. Okay, on the next example, it's just an application type question to write a polynomial in standard form to represent the area of the shaded region. So you can't see it very well, but the shaded region is the section kind of between those two. So what would your game plan be, Aiden, to find the area of that shaded region? All right. I was looking for an outline, but he gave me the entire detail of it, which is great. Yep, you're going to find the area of the big rectangle and then punch out, subtract the area of the smaller rectangle. So here, just with order of operations, be careful, okay? They want this product, which is going to be a trinomial, minus this product, which is also going to be a trinomial. So when you multiply this second one out particularly, you need to keep it in parentheses because there's a minus sign in front of it, and you want the entire thing subtracted, not just the first term. Okay? So think of it as, in PEMDAS, you're doing your multiplication first. The subtraction will come later. So this one's going to give us x squared plus 7x plus 12. These parentheses aren't really necessary because there's nothing in front of it, but just for visual purposes, I like to keep it organized. Minus, these parentheses here are definitely necessary. X squared plus 3x plus 2. And then when we distribute that minus sign, x squared minus x squared is a wash. 7x minus 3x is 4x. And 12 minus 2 is 10. Okay, now, how many of you look at that and think, well, let me do that? Is there anybody that thinks that? So you're well trained, right? Because that should pop out as being like, oh, there's a lot of, even, and you're just used to thinking that. You have to pay attention to directions, though, because this says to write a polynomial. This right now is no longer a polynomial. So if they want it to be a polynomial, you just want it simplified, which means distribute, combine like terms, and be done. Do not then factor. Okie doke. And again, I'm just pointing out and kind of calling your attention to mistakes I see kids make over the years that hurts them on assessments. And it's not really what I'm teaching, but it is important that you know those details and directions. Okie doke. All right. What do we have? How about, since we've got enough time left, go through and do each one of these on your own, and then maybe I'll collect 4 papers and we'll take a peek at them. On the fourth example, there are some bigger numbers that I would not throw at you necessarily without a calculator. So if you want to pull it out for that fourth example, you're welcome to. I'm going to do it that way. As you guys finish, you can look up at the board, and it's now all done up there for you to check your answers. Any questions? Anything? I didn't really use any shortcuts at all in the first one. I just went through kind of double distributing. On the second one, I just realized they were conjugates, so I got myself the difference of perfect squares. And then I realized that these were conjugates as well, and I got myself the difference of perfect squares. I should have known that 25 times 25 was 625, but I did some long multiplication there quickly. And then on the next example, I used the conjugates, the fact that it was 8y plus the binomial and then 8y minus the binomial. So I squared the 8y to get my 64y squared, and then I squared the binomial to get the minus trinomial part, and then just distributed that negative. And then on the last one, I just did my 8x minus 5 squared shortcut first to give me this trinomial times the binomial, and then here's where the numbers just got a little bit ugly. Audit my work. Did I make any mistakes? Because that would not be abnormal or unusual, I guess. All right, so the last two pieces of info on there, if you're ever asked for the degree of a monomial, like, I don't know, 8x squared y cubed. What's the degree of that monomial? Anybody and everybody? Do you know the degree of this? What do you think, Andrew? 5. Very good. It's the sum of all variable exponents within the term. So this one would be 5. How about the degree of a polynomial? Like, what would the degree of this polynomial be, do you think? Tom. Oh, Tom's not in here. Is there a Tom in here? Wrong class. I already moved forward on you. Trista. What do you think the degree of this polynomial would be? So you added 3 plus 2 plus 1, right? That's the rule for monomials, to add up these. In a polynomial, this is just a degree 3, right? So that would be a third degree polynomial from last year. Whatever that biggest monomial degree is. So it's the same degree as the highest degree term. So that term has the highest degree, that monomial has the highest degree of 3, so that is the degree of the entire polynomial. Okay? So just some vocab there. All right, so we're in P4, pages 49 to 50, 3s and 7s, 1 to 100, and quiz tomorrow. Okie doke.